Hello everyone. In this video, we will discuss another theory for description of the acid and base, that is hard and soft acid base theory. In the previous video, we have discussed about the various other theories of the acid base theory, that is we have discussed Arrhenius concept of acid base, Bronsted-Lowry concept of acid base, and last one is the Lewis acid base concept that we have discussed in the previous video. Now in this video we will discuss what is hard and soft acid base theory. And before going to discuss these things in details, now let us learn what are the learning outcomes of the present video. So after studying this video, you shall be able to understand the Sahab theory of, that is soft and hard acid base theory of acid and bases, through which we can classify the acids and bases in different categories of class A and B. Yeah, we can say that is soft and hard category. We can classify acid and bases as hard and soft category, identify the conditions for favorable and stable compounds using hard soft acid base theory, and you can also know the applications of SAP theory by watching this video. Now, what is hard and soft acid base theory? So it was in 1963 that was a scientist, that is Ralph Pearson, that introduced the hard soft acid base theory principle in 1963. According to that, hard acids they prefers to coordinate the hard bases, while soft acids prefer to coordinate to the soft bases. And this is very simple concept. It was used to rationalize a variety of chemical information as an attempt to unify inorganic and organic reactions in different areas. Further, in 1983, by Ralph Pearson and Robert Parr, the qualitative definitions of SHAB was converted to a quantitative one by using the idea of polarizability. According to that, a less easily polarized atom or ion is referred to as hard category, while a more easily polarized atom or ion is referred to as in the category of soft one. Now let us discuss what is polarizability. We know that the capacity of a group of atoms in a molecule or an ion to polarize the electron, that is referred to the polarizability. As in this case, we are seeing the in case of ammonia molecule. So here after polarization, it is getting this plus charge on the partial plus charge on the hydrogen atoms, while partial negative charge on the nitrogen atom. So that is called as polarizable. This is called as polarized molecule. Now what is polarizability? On the basis of polarizability, we can classify chemical species into two categories, that is the hard and the soft. So what are the hard species on the basis of polarizability? So we can classify the species as hard when a less easily polarized species, and that cannot be easily polarized, so that is referred to as hard category, and they can make the electrostatic attraction, that is ionic type of interaction by between them. Similarly, soft species can be categorized a more easily polarized species referred to as soft category, and in which they can make a covalent interaction by sharing electrons between them. So that type of species are referred to as soft category. Now, in 1963, as we have discussed in the previous slide, they classified the Lewis acids, particularly basically the metal cations and Lewis bases, into two types. First is the hard acid. What is hard acid? Hard acid is basically the one species which has a strong tendency to accept electrons. And what are the various silent features of the species to become a hard acid? That it should have small size. Species should be in the small size. They have high positive charge like +3, +5 positive charges, and they should have high polarizing power so that they can become in the plus part, and outer electrons are not easily distorted in case of that species. And further, at last, they should have high ionization potential, that they can easily ionize the species, they can easily release the electrons so that they can convert in the cationic form. Thus, alkali and alkaline earth metals and transition metals like we have Ti4 plus, Fe3 plus, CO2 plus, these are basically considered categorized in the category of hard acid. Now, how we can classify the species in the category of soft acid? How we can define soft acid? Basically, soft acid is the one, yeah, that is species which has very weak tendency to accept the electron. So that type of species are referred to as soft acid. And what are the salient features to become a species into the category of soft acid? That they should have large size, and that means species which should be considered category of soft acid, they should be a very large size. They should have low or zero oxidation state, that is we are having plus 0 or plus 1 state, that is 0 and very low oxidation state. They should have low polarizing power, and the outer electrons are easily distorted in case of species that should be considered a category of soft acid, while the species should have low ionization potential. Then when the species is satisfying these conditions, so that should be categorized in the category of soft acid. So we can say that heavier transition metals like we have Cu2 plus ion, Ag plus ions, Ag2 plus ions, and metal ions in metal carbonyls are categorized in the category of soft acids. Now, what are the various key characteristics for the species to become as hard acid, hard bases, soft acids, and soft bases? So, in this chart, we can show the different characteristics for the species to categorize in hard acid and bases, soft acid and bases. For the species to become a hard acid, that species should have low polarizability, it should have high positive charge, it should be in the small in size, it should not be easily oxidized. While to become a hard basis, species should have low polarizability, they should have spread donor orbital, they should have high electronegativity, and they should not be easily oxidized. And for becoming a soft acid species in this category, they should have high polarizability, and they should also possess low positive charge, and species should have large size, and they should be easily oxidized. Then it can be categorized in the category of soft acid. Similarly, if we are discussing a species that should consider in the category of soft bases, then species should have high polarizability, they should diffuse donor orbitals, and they should have low electronegativity in case of this one, and they should be easily oxidized. When any species they are satisfying these conditions, so they should be categorized in the category of soft bases. The HSab concept, that is hard and soft acid base theory concept, it is now widely used to explain the stability of the compounds, various chemical reactions in terms of their mechanism and pathways. So we can utilize this HSab concept to explain various things. And a theory is used in contexts where a qualitative rather than the quantitative description would help in understanding the predominant factors which derives chemical property and the reaction, so that can be utilized for this purpose. Now let us discuss what is the principle of hard and soft acid base theory. According to HSab concept, hard acids they basically prefer to bind with the hard bases to give the ionic type of complexes, whereas the soft acids prefer to bind with the soft bases to give the covalent complexes. It is sometimes referred to as soft, hard, and soft interaction principles also. If we discuss, suppose there is a difference in the electronegativity is very large between the hard acids and hard bases, so they give rise to strong ionic interaction between them. Similarly, the electronegativity of soft acids and soft bases are almost the same, hence they should have very less ionic interaction in between them. That's why interaction between They are not ionic type, but they are forming the covalent type of interaction between them. And the interaction between the hard acids and soft bases, or we can say reverse soft acid or the hard bases, they are basically mostly polar covalent. That's why they tend to be more reactive or less stable. The polar covalent compounds readily form either more ionic or more covalent compounds if they are allowed to react. This is the principle of the HSAB theory. And if we discuss about there is a difference between the electronegativity is very large between the hard acids and the hard bases, so they should give the strong ionic interaction. And if electronegativity difference between the soft acids and soft bases are almost same, so they should have very less interaction. That is, interaction between these are purely covalent type in nature, and the interaction between hard acids, soft bases, or soft and hard bases are mostly covalent. That's why they tend to be more reactive or less stable, and the polar compound that readily form either more ionic or more covalent compound if they are allowed to react. As in this case, we can see that key hard bases or hard bases they can prefer to combine with each other due to the large electronegativity difference between them. But they are less, they cannot react with the soft acid or soft bases with each other. Similarly, soft bases can easily make interaction with the soft acid, or soft acids can make easy interaction with the soft base that prefers interaction between them due to the low electronegativity difference between them. That's why they prefer to make less ionic interaction between them to form the covalent type bond, while in case of hard acid and hard bases they should prefer to make strong ionic type of interaction between them. Now, what are the applications of HSAB principle, that is hard and soft acid base principle? So there are numerous applications of HSAB principle that they can be utilized in hydrogen bonding. This can be utilized for metal ligand interaction in metal complexes. It can be utilized to predict the direction of inorganic reactions, and that can also utilize for solubility of species in the water. Now let us take one by one. First application of HSAB concept is the in hydrogen bonding. So when we know that the strong hydrogen bond is possible in case of H2O, NH3, and HF, since the donor atom, that is FON, are hard Lewis bases, and their interaction with the partially positively charged HIN, which is hard acid, are stronger. So that's why it can be utilized in the hydrogen bonding. Similarly, another application is the linkage of ambident ligands to metal atoms. So it is one of the most important application of HSAB principle, and the SCN negative ion ligands is an ambidentate ligand which can donate electrons from both sides and can be S bound to the metal, that is MSCN, referred to as thiazonate, or it can be nitrogen bonded to the metal, that is MSCN, it is referred to as isocyanate. So the choice among the S-bound or N-bound is decided by the soft or hard acid-base behavior. S is a comparatively soft base than the nitrogen atom, and soft metal ions are S-bound while hard metal ions are the N-bound. Like we can see in this case, HCN minus bond through sulfur atom soft base when bonded to the platinum 2 plus a soft acid, and it bonds through the nitrogen atom a hard base when linked to the Cr3 plus a hard acid. When Fe2 reacts with HCN negative, a bright red, that is FeHCN plus ion is formed, whereas Cr3 plus forms Cr and CS2 plus. What is the reason behind that? The Fe2 plus ion is a borderline acid and acid is bound with the sulfur, whereas Cr3 plus is a hard acid prefer to bound to the N bond. Now, another application of HSAV concept is to predict the direction of inorganic reactions. So this principle is mainly utilized to predict the outcome of few of the reactions. We can predict whether a reaction proceeds to the right or left based on the soft or hard acid-base interaction. The first reaction that we can see here, the reaction between the ASF3 and PI3 is possible and proceed to the right since AS3 plus ion is softer than the P3 plus and iodide I minus ion is softer than the fluoride ion. So that's why we are getting this reaction product ASF3 plus PI3 when they are interacting with each other. So we are forming the ASI3 plus PF3. Remember in both cases that is AS3 plus PA3 plus are soft but relatively AS3 plus is softer due to the large side. And the second reaction to predict the direction of an organization is the reaction between MgS and BaO. As shown below is the possible since Mg2 plus ion is a hard acid, then the Ba2 plus and O2 minus is harder than the base S2 minus. Similarly, in this case, we have MgS plus barium oxide, and then we are getting the magnesium oxide plus BaS. Then this is the category of this one. Now, another application for HSAB concept is the solubility in the water. Do we know that the compound which is formed due to the soft acid soft base combination is mostly covalent in nature and less soluble in the polar solvents like we have water. For example, if we are taking example of silver iodide, that is AgI, it is insoluble in water as it has covalent nature since it is the combination of soft acid Ag plus and soft basis I negative. On the other hand, lithium iodide. Lithium is the result of combination of lithium ion that is hard acid and I negative ion that is soft basis. Thus, it is polar covalent and thus soluble in the water. Now at last, what is the summary of present video? According to HSAV concept, hard acid prefers binding to the hard bases to give the ionic type of complexes, whereas soft acids prefer binding to soft bases to give the covalent complexes. Similarly, hard Lewis acids are characterized by small ionic radii, high positive charge, strongly solvated in nature, while soft Lewis acids are characterized by large ionic radii, low positive charge. While hard Lewis bases are characterized by the small ionic radii, strongly solvated and highly electronegatively weakly polarizable, while soft Lewis bases are characterized by large ionic radii, intermediate electronegativity and with high polarizability. And HSAB principle is used to predict the outcome of few of the reactions. We can predict whether a reaction will proceed to the right or left on soft or hard acid-base interaction. These are some of the practice questions that can be solved on the basis of present video. And these are some of the references that I utilized for making this video. At last, thank you for your kind attention.